Hello everyone, welcome to this video on estimating simple linear regression model. This video is from Slow and Steady Economics and Research 2. So in this video, I will be using this data file to estimate the equations. This is the data set for which we are going to estimate the simple linear regression model. So to begin with, y is equal to beta 1 plus beta 2x. This is the general form of the linear regression. In this, x is the independent variable and y is the dependent variable. So that means a unit change in x affects the y variable, that is dependent variable. So the changes in the dependent variable is caused by a unit change in the independent variable, that is x variable. So in our model, food expenditure is the y variable, that is dependent variable, and income is the x variable, that is independent variable. So x is income, independent variable, and y is food expenditure, that is dependent variable. So now the linear regression will be food expenditure is equal to beta 1 plus beta 2 times of income. So this is the form of the linear regression for which we need to estimate the beta 1 and beta 2 values, which we call as OLS estimates. So what is beta 1? Beta 1 is the intercept term and beta 2 is the slope coefficient or parameter, anyways we can call it. So what does beta 1 and beta 2 says? Beta 1 says irrespective of the level of income, even the income is zero, there will be some amount of food expenditure that a person will make. And what does beta 2 says? Beta 2 says that how much level of income affects the changes in the food expenditure. So that is what beta 2 says. To estimate these two, in this video, I will be going to use two different methods. One is the standard formula method. So here we will be using the OLS formula for beta 1 and beta 2, and we will be plugging in the values to the formula to derive the beta 1 and beta 2. The next method is the inbuilt method. That is, MS Excel has inbuilt function to find the values of beta 1 and beta 2. So in the later part of the video, I will show you how to use the inbuilt function of the MS Excel to find beta 1 and beta 2. For now, we will be using this formula method to derive the values of beta 1 and beta 2. So what is the formula for beta 1 and beta 2? Is for beta 1, the formula which we are going to use is y bar minus beta 2 times of x bar. This is the formula to derive the intercept term. And then for the coefficient, slope coefficient, the formula is summation of x minus x bar into y minus y bar divided by summation of x minus x bar the whole square. So these are the two formulas which we need to find the values and plug in those values here to find the beta 1 and beta 2. So first initially we need to find the value for y bar and x bar. Okay, let's find the values for y bar and x bar here. Y bar is equal to x bar is equal to. So what is y bar? Y bar is nothing but the mean value of the dependent variable, that is y. So in our model, food expenditure is the dependent variable. So we need to calculate the average value for food expenditure. For that, the formula is average, and we need to select the range of food expenditure. So I have selected from A2 to A41. to find the value for the mean of food expenditure. Similarly for x bar is the mean value of x, that is independent variable. So in our model, income is the independent variable, so we need to find the average value of income. So similarly here I'm selecting from B2 to B41 cell, B2 to B41 cell. So we have calculated the values of y bar and x bar. Now the next step is we need to find the values for x minus x bar, y minus y bar, and the multiplication of both and the square of x minus x bar. So here x minus x bar is nothing but x deviation, and y minus y bar is y deviation. So now on I will call x minus x bar as x deviation and y minus y bar as y deviation. Let's find the values for those things to derive the value for beta 2, because we need beta 2 value to estimate the beta 1. So first we will be estimating the value for beta 2. So what are all the things in the formula which we need to find is x deviation and y deviation, and the next thing is x deviation into y deviation. So this comprises of the numerator part of the formula, and for the denominator we need x minus x bar the whole square, that is x deviation square. So now we need to calculate the for x deviation. So what is x deviation? X minus x bar. So what is x? Income. Income is the independent variable. So x is income, B2 cell minus x bar. Here we have calculated the x bar, that is E5 cell. So this is the value of x deviation for the first unit of income. Similarly, we need to calculate for all the units of income. So what we need to do is we need to apply the formula to all the cells. But here x bar need to remains constant across all the units of income. So I'm adding dollar sign to make it constant. So now this x bar value E5 cell will remain constant. So to apply to all the cells, you need to click on this dot in the right corner of the cell and drag it to the end, for which you need to calculate the value. So you can randomly see that this E5 cell remains constant and this changes for every unit. Similarly, we need to do for y deviation. Y deviation is y, what is y? Food expenditure minus y bar, which we have calculated here. So this is the y deviation for the first unit of food expenditure. Similarly, we need to apply for all the units of food expenditure here. So here also I'm going to make this E4 cell as constant by adding a dollar sign. So now after adding, you can apply to all the cells to which you need to calculate the values. So now we have calculated the value of y deviation for all the units of food expenditure. So and then moving on to the x deviation into y deviation. So this is the full part of the numerator of the formula. So that is what we have here, x minus x bar into y minus y bar. Sorry, the formula is not applied to all the cells here. 1 minute. Okay, now it is completed. Here x deviation into y deviation. So this is the value of x deviation into y deviation for the first unit of food expenditure and income. We need to apply this to all the units of food expenditure. So I am dragging the formula for all the cells. Okay, now we got the value of x deviation and y deviation. So this is the thing which we needed for the numerator. Moving on to the denominator part of the formula, that is x deviation square, x minus x bar the whole square. So we need x deviation square. Similarly, we need to apply to all the units of income. Okay, now we got the value of x deviation square for each unit of income. What for the formula, we need summation of x deviation into y deviation divided by summation of x deviation square. So we basically need the sum of these two columns. So that is sum of x deviation into y deviation is equal to, and for the denominator part we need sum of x deviation square, right? So we need to calculate the values for sum of x deviation into y deviation, that is numerator part, and the sum of x deviation square for denominator. So what is the formula to calculate the total value of this? That is sum, and we need to select the range for which we need to find the sum. So we need this column. So I'm selecting the column. Sorry. So I2 to I41 I have selected. So we have calculated the value for x deviation into y deviation. Similarly, for x deviation square, we need the sum of this column, x deviation square column. So I am selecting from J2 cell to J41 cell. So this is the sum of deviation, x deviation square. This is the sum, sorry. So this is the sum of x deviation into y deviation square. So we have calculated the values for both the numerator and denominator. Now we need to plug in those value into the formula to find the value of beta 2. So before estimating beta 1, we will be finding the value for beta 2. So what is beta 2? Sum of x deviation into y deviation divided by sum of x deviation square. So this is the value for beta 2 which we have estimated using the OLS formula. So now moving on to estimation of beta 1. So what is beta 1? Y bar, that is 283.57 minus beta 2 10.209 into x bar 19.60475. So this we will get the value of beta 1, that is intercept term. Beta 2 is the slope coefficient. So after estimating beta 1 and beta 2, I will be writing the full regression equation, that is food expenditure is equal to, what is the value for beta 1 which we have calculated, 83.416. okay, so 83.416 plus what is the value for beta 2, 10.20964. so 10.20964. so this is the value of beta 2 and this is the value for beta 1 into income. So this is the regression equation which we have estimated using formula. So this is the equation. Now moving on to the second method, that is inbuilt method. Now we have completed this one. Now we are going to look on the inbuilt function which we will be using to find the values of beta 1 and beta 2. To use the inbuilt function, go to the data and the ribbon. In the right corner, you will be seeing this option as data analysis tool. That is the tool for financial and scientific data analysis. So click on that. In that, you will be seeing a lot of analysis tools which Excel has as inbuilt function. So in that, search for regression, click on regression, then click OK. So this is the regression dialog box which appears in the MS Excel. So in that, you need to put in the values of input Y range and then input X range. So in our data set, what is Y? Food expenditure, and what is X? That is income. So now we need to input those ranges. So what is Y range? Food expenditure A1 to A41. This is the range of input Y. And for X range, X, what is X? Income. Income is the independent variable. So we need to select the range of income. So from B1 to B41 I'm selecting. So after selecting the range of both the dependent and independent variables, we need to check this tick box, that is labels, because as you can see, I have selected from the A1, that is the one minute. So you can see I have selected from the first cell, so that contains the label of that range. So I am ticking this as a small select box, that is labels. So the Excel will consider first cell as the heading of the range, and the confidence interval is 95%, the standard confidence interval. I'm just going to leave it as it is. And you can give the output range. If you want the output in the same data sheet, you can select the output range. So Excel will display the output in the same Excel sheet. For now, I'm going to select this new worksheet. So I'm going to name this new worksheet as result. So this Excel will give me the result in the new worksheet here near to this food data, which is named as result. So click on OK. So as you see, I have got a new worksheet named as result. This is the Excel result for regression analysis. Okay, so this is how the regression equation for this data set has been given by the Excel. So in this summary of output, we are going to concentrate on these two terms, that is coefficients. So intercept is nothing but beta 1, which I am saying in this video, and income coefficient is beta 2, the slope coefficient of income. So these are the two values of beta 1 and beta 2 which the regression function in the Excel inbuilt has given us. So with this function, I'm going to write the regression equation, that is food expenditure is equal to beta 1. What is the value for beta 1? 83.416 plus what is the beta 2 value? That is 10.20964 into income. So here so this is beta 1 and this is beta 2 value. So cross checking with the regression equation which we have estimated here, you can check that both the values of beta 1 and beta 2 are same using the formula method, and the regression output which is given by the Excel inbuilt function. So apart from the values of beta 1 and beta 2, the regression output gives so many other values. Interpretation and the explanation for the other output variables which the regression inbuilt function given will be seen in the next upcoming videos. For this video, I'm going to stop with this. Look for more videos. Thank you.